Okay, a very big welcome to everyone to Denby Dale Amateur Radio Club, and I'm delighted to welcome back Anthony K8ZT and Dennis W6DQ for their talk. The title I think you gave us, Anthony, to start with was HF for Beginners, and tonight you were going to have a look at and talk about antennas and equipment on which we could all chip in. And I made the point in my email roundup to our members for tonight's meeting that we have got people in the audience tonight who I know are very new to amateur radio, some of whom who started doing their licenses during COVID lockdown, but obviously at the beginning of their journey playing with this fantastic hobby that we all play with. And we've got people in the room I know who have been radio amateurs for more than 50 years, and we've got some who have only been playing with this hobby for the last year. So that kind of audience is fantastic for a discussion tonight, because everyone is able to chip in with ideas and comments. So without any further ado, I'm going to hand the microphone over to Anthony first of all. And Anthony, I'm going to get the apology in on your behalf. You've been struggling yourself with an illness, and you did make the point that if you come down starting to cough, and I'll just make the offer to you now, if as you're beginning to make your presentation, you don't feel well enough to continue, it's absolutely not a problem. We can reschedule it for the new year, I'm quite sure, or we can bump your third one to the second one and do it again. It won't be a problem. So we're in your hands really, Anthony, in terms of whether you're well enough to continue tonight.
I think I should be able to do it. That's one of the wonderful things about online. Yeah. I definitely would not be able to do this at the meeting, but I may have to pause occasionally to cough. So just be aware of that. And I'm controlling the slides also. So Dennis is at my mercy. So good evening, everyone. I'm Anthony Luskery, K8ZT.
And I'm Dennis Kidder, W6DQ.
And I have the beginning slide up here because it's at the beginning of the slideshow, but that's not where we're going to start. So this is what we're calling the Beginner's Guide to HF Operation, the UK version. And last week we covered a number of things. Let me just quickly bring that up to give you an idea what we covered in the first week. We covered the magic and characteristics of HF band and operating on HF. And again, the recording of this is available and the slideshow is available. What we're going to be doing tonight is we're going to be starting with acquiring equipment, antennas, and feed lines. So let me go ahead and kick this into slideshow mode. And get the right list up here.
You got it.
So we put together just a little montage just of some pictures of rigs that are currently available. These are some state-of-the-art rigs. You'll notice the digital controls on them all, the band maps and waterfalls on some of them, the computer control of the Flex 6400, and these are not necessary to scale, but this is definitely the smallest one, this little monoband QRP Labs QCX Plus. And then we decided to go back about 15-20 years, and these are some of the radios that were very popular. Again, you're noticing all digital displays, but you're noticing some older style digital displays. You're not seeing the LED displays that we're seeing on most of our current rigs. And then we decided to take a step back and look at stuff from 85 back. And you'll notice that we have a lot of analog dials here, a few digitals, and a wide variety of radios, including this is a picture of my original radio as a novice operator, 1981. I purchased this. This is a Ten-Tech Argonaut 515. I still have it. I still take it out and play with it occasionally, and it's still fun to play with. And a lot of these radios are radios that Dennis has in his shack there. Dennis's shack is not really so much a shack as a giant radio museum.
But yeah, between the two of us, I think we've owned just about everything that's on that page.
Yeah, I think that's pretty cool, pretty accurate. So we're going to talk tonight about HF radios. So we're going to skip this first part on VHF, but you'll see that VHF and UHF does come into this some, because really when you're choosing an HF radio, there are HF radios, and then there's HF radios that have a combo of HF, VHF, and UHF. Now, what you gain with the VHF and UHF is something that you might be interested in or might not be. And sometimes you're going to find that some of these are not really the highest performing radios, although some of them do have good performance. But we're going to be focusing mostly on HF radios, but just realize there are a variety of radios. And not all HF radios are all bands, but most of them do 160 through 6 meters currently. So you do get one VHF band included with that, but there are mono banders available out there. There's base radios, portable radios, single band radios. So we have two very portable radios here. This is a 100 watt FT891 from Yaesu, and this is a KX2 from I'm sorry, it's KX2 from Elecraft. So this chart, I know it's a little hard to focus on this, but I tried to get a bunch of information in here. And please realize that all the rows are independent of each other. But what we're going to do is look at a specific feature, for example, power output. And we're going to talk about typically what you get and some of the alternatives in the radios that you're looking at. So as far as output power, if you go out into your favorite ham store, you go online and look at HF radios, most of them are typically going to be about 100 watts output. That's very typical of most radios nowadays. There are alternatives. There's QRP radios available, and there are a few radios that put out 200 watts. That's pretty much the maximum as far as high power goes. Whether the 200 watts makes a difference versus the 100 watts is debatable, but just realize that some radios do have that capability. As far as bands go, typically, if you buy a multi-band radio, you're going to get 160 through 6 meters, although a couple of the multi-band radios do not include 160 and 6. So for example, that KX2 I showed you earlier has all the bands but those two. And the alternatives are single band, or there's also some quad band radios out there. Quad band radios typically have 80, 40, 20, and 15 or 10 as their fourth band. And then, as I mentioned, some of the radios do have VHF and UHF added to them. As far as form factor goes, base radios, mobile radios, and portable radios are the ones you're going to see. Battery operated is typically not the case. Most of these radios require an external power source, usually a AC power source that gives you 12 volts. But some of the radios do have built-in batteries. These are mostly portable radios, mostly low-powered radios. You can also have an external battery pack to do this, and you can even run a 100-watt radio as long as your battery pack is sufficiently large. Sound card is typical in most new radios. There are a few new radios that do not have, but most of the new radios have a sound card built in. Well, why would you want a sound card? It lets you operate FT8 and other digital sound card modes very easily without having to have an extra accessory such as a signal link or something of that nature. Now, the alternatives are, if your radio doesn't have a built-in sound card, to use an external sound card interface device. Something easy to do. If you're looking at features, as far as tuning the radio goes, typically the radios have knobs. They have a traditional faceplate with knobs on the front you can twist. A couple of them have up and down buttons, but most of the knobs are typical turn the knobs. Alternatives are computer-controlled radios, such as the Flex SDRs, where there's no knobs on the front, no controls basically other than a power switch, and you need a computer to control all the operation. Now, in addition, some of those radios have the option of an external control panel. So you can buy a Flex with an external control panel. You don't necessarily need to have a computer to operate a Flex radio. As far as mixing schemes,
Anthony,
go ahead.
Just interrupt. There are Flex radios that have a front panel now.
Yes.
I've had those for some time. So they do have, and they actually do have knobs on the front panel. So you don't have to have a computer to run it.
Yes.
And if you have one of the ones that doesn't have a front panel, one of the things that I have is what they call the Flex Control, which is actually a single knob with some push buttons that you can use to control the radio with if you got to have a knob. And I use it primarily for a volume control of all things. So there you go.
Yeah, and you know, the funny thing is, probably the two biggest things we need is a tuning knob, but even more important is a volume knob. And I have one radio that has a traditional tuning knob, but it has an up-down volume control on it, and it's the weirdest thing to use. One of my Zygoos has that, and you're always like pushing the wrong button. You're always turning the sound the wrong way. And my wife always yells from across the room when I accidentally turn the sound way up instead of down. The next one is a little bit complicated, but we're just going to try and keep it simple for this purposes, but it's definitely beyond the simplicity of this chart. And that's what I'm going to refer to as the mixing scheme. And for the mixing scheme, typically most radios use a super heterodyne type of configuration for years and years and years. That was sort of the standard for most HF radios in the amateur radio field. But alternatives started to come in a few years back, including SDR, direct SDR, or hybrid SDR. Also, some radios like the Elecraft K2 and K3 really brought in a whole wave of direct conversion radios. These are radios that didn't use a super heterodyne mixing scheme. They did more of a direct mixing scheme. And I have in the presentation, when you download the presentation, you'll be able to click on these links for more information on what I'm talking about in this particular thing. This link, of course, all three of these links go with the mixing scheme. They don't go with the performance. So you'll hear the term SDR being bounced around by a lot of the manufacturers because it's a very popular buzzword. It means software-defined radio. And really, most of the radios on the market now have, to some degree or another, a lot of the mixing scheme involves software as part of the aspect. Software has really became very important in almost all these radios, and updating firmware is very common now. So a lot of modifications can be made to radios after they're purchased and in your shack. Some people like hybrid SDR. So if you're looking at, for example, something like the Yaesu FT DX10, which is a very popular radio that came out in the last year and a half, I guess, it has a more conventional front end before it gets to the SDR. Whereas if you look at something like the 7300, it has more of a direct into SDR type of mode. But I don't want to get too hung up on this part of the thing. As far as performance goes, typically most of them have very good performance. It's not really an issue that much anymore. You can get better performance if you want to spend some money for what I'm going to refer to as high performance radios, but you can definitely under $1,500 get a very high performing radio. Now you can go in the other direction. You could go to a very economical radio, something in the $300 to $500 range. Some of the what I'll refer to as Chinese imports, such as some of the Zygus, you're gonna not get quite as many features or performance, and you could even go a lot lower in the ecom range and purchase a under $100 single sideband radio on eBay. Very experimental in some respects, but still can make contacts. As far as vintage goes, your alternatives are basically to buy a current radio or buy what I'm going to call a used modern radio, and that's a radio that's post 2000. Or if you want to go back in time, basically we sort of group the time periods as 1980 to 1999, about a 20-year span. And then the 1970s radios where you were still seeing some hybrid radios that use both solid state and tubes in them, valves in them. And then pre-1970 was almost exclusively valves or tubes in the radios. As far as new or used go, typically a lot of people buy new, but there are a number of alternatives. You can buy a current model that's used or buy a vintage model used. Of course, that's the only way you're going to get a vintage model because there's no new vintage radios out there being sold. So that's the whole chart, and I know that it's a little bit involved. The thing is, not all HF radios are equal. Some are better at one thing than another. Some are better at CW than others. Filtering built into the radio is a key. And in previous years, if you wanted to get good CW filtering or good single sideband filtering, you often had to spend a lot of money after you bought the radio to put in aftermarket filters. And one of the things that's really happened over the last couple of years is that is not a necessity that it was before. You can get radios with very good filtering from the new radio when you buy it at the factory. It comes from the factory. So adding filters is not as common as it was before. And if you're looking at used radios, remember if the radio requires this external filtering and it's a very good price, it might not be a very good price after you add the filters that you want into the radio. So just be aware of that when you're pricing out used equipment. The other thing about CW radios, some people prefer radios that have very quick turnover time and don't use relays for switching the keying. So if you've grown up with 10-tech radios and you switch over to something like Ieyasu, you might be a little bit disappointed with the clanking of the relays and keying, but it just depends what you're used to. Some radios work great for single sideband, but if you want to operate digital, you might need an external sound card interface. Some have built-in antenna tuners, but you have to be aware that some of these built-in antenna tuners have very limited ranges, less than 3 to 1. Others can tune very wide ranges, up to 10 to 1. You may not need it if you're using resident antennas or feeding an amplifier. You may be doing, the tuner may be superfluous. Not all radios are equal. Some have built-in sound cards, mostly newer models. But you can use an external sound card interface for around $100. If you do not operate these modes, it may not be useful at all. So you may want to pick it up. The sound card can be useful for other things besides doing digital modes. If you want to send single sideband messages for contesting software macros from something like N1MM contesting software, you can feed that through the digital sound card. You can also record on-air audio to a computer. Some radios also have the ability to capture on-air audio recordings on the fly to a storage disk or storage memory on the radio. They're also useful if you want to work traditional digital modes like RIDI. You can do it very easily with the sound card interface. Used radios are great buys, and other used radios are projects at best. So when you're buying a used radio, it's sort of buyer beware. You might be getting a great deal, but you might be getting a unusable piece of junk. Not all radios are equal. Some cheap radios may actually cost more after adding missing features, filters, antenna tuners, other features that you might want. Sometimes the solution is actually to own 2 or more radios, and this is a secret I always tell our new students when I'm teaching a beginner's class. They're so worried about that first radio they buy, and I warn them that's not going to be the only radio they'll probably buy. If they really become an amateur radio operator, you really know when you've been in the hobby for a while when you don't know how many radios you actually own. That's one of the keys to being a long-time amateur radio operator. So a lot of times I tell people as they're stewing over making that decision on HF radio, sometimes buying a starter, inexpensive used radio until you get an idea of what you really want or need for HF is a good way to start out. Or you might want to consider buying an inexpensive compact QRP radio for use while hiking, for POCs on the air, or even a 100-watt mobile for a vehicle. And these are usually an inexpensive way to get started in the hobby. And then if you really like it, you can spend more money and get a more traditional 100-watt base radio with the features that you want. So sometimes it's actually cheaper to start off and buy 2 radios than it is to buy one really expensive radio that you might not be that thrilled with. So the thing I want to mention now is if you're just getting started and you don't have an HF radio to listen to, a great way to get started is using online software-defined radios. And I do this all the time with youngsters. It's a great way to provide a free radio to people with a great antenna, great tuning capability, single sideband support, and the ability to put it anywhere in the world you want to listen. So I have a whole presentation here. It's at tiny.cc/freerx. And this is what I use with the school students or the youngsters. It talks about what we're doing, how to get to the different sites where they're at, examples of how to tune the online radios, both the WebSDR typical interfaces and the Kiwi interfaces. I give them information on some other sources of online software-defined radios, and even something that's just commercial. This is not shortwave, it's not amateur, but it's just commercial radio. And you'd be surprised how many students have never actually tuned a radio before. They're used to just telling their device to play audio or using a streaming service that they subscribe to. I have some information on shortwave listening, and then some information on band plans, and then I provide DX Summit and DXscape so they can look for stations, see a station where it's located, and then try and tune it in on the radio. So that gives them a frequency where they're most likely to find a station. I give them a chart of the amateur bands in the US and more information. So this is something I can hand out to a student and they can take home and they can do it on their phone, they can do it on their computer, they can do it on their Chromebook, they can do it on a tablet. And unlike myself, when I built my first shortwave radio to listen at home, the only place I could put an antenna was stapled to the floor joist. So I was in the basement, so my antenna was actually below ground, but it was a long wire antenna that ran from one end of the house to another. But it didn't have great sensitivity. It didn't receive single sideband very well, but this is a way that you can do that. So the other thing about buying an amateur radio, I have a whole presentation at tiny.cc/buy-AR, and then I have a spreadsheet to go along with the slideshow that has a matrix of information on current and very recent HF radios, all in the under $2,000 range, talking about what features they have, which bands they cover, antenna tuners, internal sound cards, etc., and some typical prices in the US.
US dollars, yeah.
Yes. Then I also have a list of almost every vintage radio from the last 25 years for all different brands here with links to information on them. I had the same things for some VHF and UHF stuff, but a good idea of some of the equipment that's available. Now I'm gonna let's see.
Yeah,
that's it. Now Dennis is up.
Cue me. All right. Well, Anthony's been talking about the transceiver. We want to talk about the components that you use to put together a station. So a station's actually a system. It's a conglomeration of various pieces. Your HF transceiver, the radio that you've purchased or obtained, may have an internal power supply, but it may have an external power supply. A typical 12-volt mobile radio or some of the 12-volt base radios require an external power supply to supply 12 volts. You need an antenna, of course, and you need a way to be able to feed the signal from the transceiver out to the antenna, and typically that will be coaxial cable. And if the radio doesn't come with one, you need a microphone. Most modern radios these days do come with a microphone, a handheld microphone, but you may prefer to have a desktop microphone, something like this kind of thing here that you don't have to hold in your hand. And or if you're interested in using Morse code, you're going to want to have a telegraph key to be able to use with that. And that can be the form of a straight key or a keyer or whatever you favor. Go ahead. So this is your typical station. You see, in this case, we've got the Yaesu 991 there on the right with a little handheld microphone. You've got a 12-volt power supply, and very important to have a fused power cable going to that radio. And whether it's on your desktop or in your car, if you're running a radio mobile, you still want to have that fused line because you never know. And if you take a good look at this, both the positive and negative sides are fused. That's important. Coax, you see he's got a piece of what looks like RG8 coax, which is one of the most common coaxes that you would use, with a PL259 UHF connector on there, a PL259 plug. So there's your basic setup, and that coax is going to go out to the antenna. Go ahead. So other things that you might want to have, depending on the antenna that you're using, an antenna tuner, we'll talk more about that a little later. Antenna tuners are typically built into most radios, but some do not, especially older radios do not have a tuner built in. So you may have to have that, and that's to come up with a proper impedance match between the transmitter and the antenna. Anthony mentioned the sound card interface. Many of the radios, even the older radios, have what they call a digital interface on the radio that you can use to hook up to a sound card, like a Signal Link or something along those lines for doing digital modes. A keyer, an external keyer, is a great thing to have if you're into using Morse code. Automatic keyer using paddles makes life much easier and makes it a lot easier to transmit at higher speeds. A voice keyer is kind of a neat item, and Anthony kind of alluded to that a little bit earlier with the contesting software. A voice keyer is basically something that you record a message, an audio message, and it's relegated to a push button on a little control panel. So one of those buttons may say CQ contest from W6DQ. And another one may say QRZ contest from W6DQ. So if you're there for 24, 48 hours running a contest, your voice is definitely going to give out after a while. So having a keyer, voice keyer like that makes it a lot easier on your voice in the long run.
And
So
you can buy this as, you
yeah,
could buy an external box like this with
right,
buttons
the
to push
MFJ.
also.
Yeah. Yep. And many of the radios have them as an integral option for the product. Yaesu has in fact, a couple of my Yaesu radios have an external voice keyer control. That's just a control panel. The keyer is actually built into the radio.
Yeah, and one quick thing on that, a
Yeah.
lot of those have the ability to run off an external keypad, and those keypads are actually very simple inside. You can buy them from the manufacturers, but they're really just a little resistor matrix in there with a different resistance triggering each of the different memories. And if you go back and look through, do a search for CQ Magazine, I had an article in there in my column on building interfaces for all the major brands of radios that work with, like the 7300, the FT 991, and a number of radios.
Yeah, I've got the one that I have that came with that was the Yaesu FT 1000 Mark V. When that came out, came with a voice keyer, which was a nice option to have with that radio. That was at the time, that was a really outstanding radio, but that's been quite a few years ago. CAT computer is basically computer automated transceiver. This is where you can actually use your computer to control the radio itself. And so this is used a lot in the digital modes, of course, to set the frequency and the mode of operation and things like that. So you actually control the radio, and when it transmits, you're actually controlling the transmit line remotely from the computer. And of course, the software to go along with it. If you're going to run a digital mode, like let's say FT8, the software W6DQ would be the software that you'd install to do that. And that provides a number of other modes as well as the FT8. FT8 has become extremely popular these days, a very, very popular digital mode. If you have a directional antenna, like let's say a Yagi antenna, you're going to want to have a rotator to be able to point that in different directions, a directional antenna. You'll find if you have a directional antenna and you've got it pointed all the time in one direction, you're not going to work anybody but whoever's off in that direction. And in a contest station, that makes sense. You might want to have, like for us here in the States, we might want to have a Yagi pointed at Europe and one pointed to Asia. And then we just flip a switch to switch between the two antennas. And we don't have to worry about rotating the antenna around. We can instantly switch directions between the two antennas. And of course, there's a control box that goes with that which you use to point the antenna. And we mentioned a coax cable and an AB switch. If you happen to have multiple antennas, an AB switch makes it easy to switch between them. Many of the new radios support multiple antennas. They'll have two outputs, two connectors. So you can have an AB built into the radio, which is nice. Makes it real easy to switch antennas. It's very, very nice to be able to do that. And of course, if you have a lot of accessories, if you have a 12-volt radio and the 12-volt power supply, and you have many accessories that also run on 12 volts, like a keyer, among other things, there's other bits and pieces that you might add. Power distribution is a nice thing to have as well, a power distribution system. So power supplies, we want to talk about two different types of power supplies, a linear power supply versus a switching power supply. Switching power supplies are great. They're super lightweight. But the issue with them is they're sometimes very noisy with RF. In other words, they will interfere with your receiver. Linear power supplies are inherently quiet, but they're heavy. They have a big transformer. So that's something to be aware of. Switchers are excellent. There are some very excellent switching power supplies that are designed to be RF quiet so that they don't interfere with your equipment. And Anthony has a link there to a talk on a presentation, or maybe that's just a web page on switching, the differences between those two power supplies, something worth looking at. Oh, that's from DX Engineering. Okay, that's their tech page. Yeah, switching power supplies are great because they are compact and small. And uh, I've got a combination of both switching and linear power supplies here. In fact, when you've got vintage equipment, the valve equipment, you're going to have linear power supplies because you're going to have the high voltage, the high tension to be able to run those radios. So that you're going to be using a linear power supply. So those are the two basic types. We talk about 12 volt power supply with the output. Nominally, it's 13.8 volts, and this is derived from your automobile. The DC power system in an automobile, typically the alternator or generator runs at about 13.8 volts. So that's where that number comes from, but we refer to it as 12 volts. Your typical 100-watt HF rig will require 18 to 25 amps during transmit, much less during receive. Don't limit yourself. If you've got a lot of accessories, you're going to want to find a power supply that can do more current than that 25 amps that's used by your transmitter. You may want to have a 30 amp or higher power supply if you've got a lot of 12 volt accessories. So that's something to be aware of. You have to take a tally of what all you've got to make sure you can cover it all. Power wiring. This is an interesting thing. You know, what we talk about IR loss in wire, it's the resistance in the wire because it's too small, and we push too much current through it, we get a lot of voltage drop on that wire. So we want to make sure that the wire that we use is appropriate for the current that we're drawing. And that's easily determined from the tables that provide that information. These Anderson power poles, if you're familiar with those, or if you've never seen Anderson power poles, these things are fabulous. They are you only need one type. They're what they call a hermaphrodite connector. You have the identical connectors that will interface each other, which is wonderful. So you don't have to have a whole set of connectors. And if we have kind of a de facto standard of the way these can be put together. They're individual pieces that you stamp together that you can kind of see in the picture there, the red and black little blocks there. So that if everybody sets the radio up the same way, you can actually interchange your equipment. You can use someone else's power supply, or they can run your radio on their power supply. And I happen to have one right here. This is actually from my ICOM that I've got sitting here on the bench next to me. I've got it disconnected from the power supply, but that's the Anderson power pole. Well, let me get it in front of the camera. There we go. And so that gives you an idea of the physical size of these. And these are good for about 30 amps. They make a 30 amp version. There's a 45 amp version, and some that are significantly larger, 100 amp, 75 and 100 amp connectors. Like
we have some 480 volt ones on the train.
Oh yeah, I'll bet you do. Yeah. They're wonderful. These things are wonderful, though. These are years ago. This was a very well kept secret, and around 20 years ago, these things started becoming very popular. And you can see there's my dual fuses on my power supply line right there. So anyway, those are the Anderson power poles, and he's got some links. I don't know whose video are those. Whose videos are those? But you've got a link to some videos.
Yeah, they're YouTube videos on installing power poles.
On installing them. Yeah, they are very easy to install, very simple.
And just an additional thing on this voltage drop. Voltage drop can present itself as a lot of strange symptoms on a radio.
That's true.
And everything from on an Elecraft K3, if the voltage drops too low, you can't turn the radio off. So it's the weirdest thing. The radio will keep turning back on no matter how much you push the power switch. So when you're getting weird results, always check the power cord. I had a radio that was putting out it would kick the SWR warning anytime I put out more than 15 watts on it. And it turns out the drop, when I measured the drop on about a 6-foot power cable, I was only getting about 9 volts on the end of it.
Ouch. Yeah,
it was a combination of bad connectors, bad fuses, and small wire.
Oh, well, a lot of the modern radios, because they're all digital and use synthesizers and things like that, if the voltage should happen to drop too low, they'll start like Anthony said, they'll start acting very strange, a little wonky. I can tell you from experience, the microwave radios, I do dabble in microwave 10 gigahertz and up. And when the voltage, you know, we build our own radios for that, or build our own transverters. And when the voltage drops below 12, well, typically down below about 10 volts, you start running into trouble where you can't hold frequency and the thing will start drifting all over the place or doing something crazy. So yeah, it's something to be very well aware of. The part of the distribution, there's commercially available distribution blocks like what he has is illustrated here. MFJ has this block that uses the Anderson power poles, and it's got a switched outlets on it, which is nice, as well as a voltmeter, which is real handy. All the individual outlets are individually fused. And I know we talked about the other one. I don't know who's that one from. Is that the one from HRB from Ham Radio Workbench? Is that the one that George did, the DC power distribution? Not that it really matters, but that's a typical Anderson power pole distribution system. West Mountain Radio makes some really great distribution blocks. Those are the ones that I use. Be wary of the Chinese imports, because a lot of times the connectors won't interface with authentic Anderson power poles. They look like Anderson power poles, but they don't work very well. So that's something I've run into before. We talk about a microphone. If the microphone is not included, you'll have to add a microphone. And there's a lot of different microphones you can add to that. In fact, the manufacturer of the radio probably has mics that are certainly available for it, whether they're handheld or desktop microphone. The CAD interface cable, the original CAD interface was over an RS-232 interface using like a 9-pin DB type connector. So those are the older radios. Nowadays, it's all done over USB. And one of the things that's important is that you have the right software, the drivers in the computer, as well as what you're talking about here, the RS-232 to USB cable, the adapters. You've got to watch out to make sure that you get the right one that has the right, and we talk about this FTDI chip. That's the converter between the RS-232 and the USB. There's a lot of the cheap Chinese imports that just don't work. And so you have to be really careful about that. Consult the manufacturer's information for the radio. There is good information from the manufacturers online for getting the right type of adapter, the right type of cable adapter. Headphones are great. A lot of times people like me that are hard of hearing, I've got very bad hearing on my left ear. Headphones are great. Much easier to listen to, and especially if the conditions are poor, you're able to pull signals out of the noise wearing a pair of headphones. It also is easy on your family members if they don't like listening to your radio. If your radio happens to be in a common area in the house, in your home, headphones are great.
Headphones are mandatory here, Dennis.
Yeah, I get that. Yeah. Yeah, so this ham shack is a separate building, so I don't have to worry about anybody being bothered by my radios here. But headphones, I do have headphones, and I don't know, you probably can't see them. There's a pair hanging up on the post there. I've got 2 pairs of headphones up there for different operation, but they're really great. But one thing you want to be cautious of, make sure you find a set of headphones that are comfortable, that you can wear for long periods of time. If you're in a contest, wearing headphones for 12 hours at a stretch can be rather brutal on your ears. So we like having headphones that are extremely comfortable. You've got the.
I find that I like different headphones for CW than I do for phone. I like a full audio range for phone, but I like communication type ranges better for CW. And I also like real light headphones. Another thing about headphones that you might not realize if you've never operated portable before, you will find that if you operate portable under certain conditions, if you don't have headphones, you will not be able to make contacts because of wind noise, road noise,
yeah.
All sorts of things that make it almost impossible to hear the radio.
These are not your typical headphones. These are rather dear, but these are great for contesting. These are from a company called Radio Sport, and they are very dear, but they're extremely comfortable. They have a built-in boom microphone, and we talk about that for hands-free. You put this guy on and you've got the microphone there. I've got both hands free to do whatever I need to do, whether it's to run the keyboard or write stuff down on a piece of paper. And these headphones are Radio Sport, and they're extremely comfortable. I can wear those for hours at a time without any problems at all. And they're extremely well made. They're very sturdy. But the other aspect of this is hands-free operation using headset with an attached mic. You can have a foot switch to transmit, which is useful. You can use that foot push to talk. You can use what's called Vox, or voice activated operation, or voice activated transmit. Vox just uses your voice and the radio will start transmitting when you talk. Of course, you got to be careful. You can't really use that in a noisy environment. And if you're like me and you like to talk a lot to yourself, Vox isn't a good idea. But Vox is a great thing. If you're, contesting, Vox is fantastic for that. But it really frees up your hands to do other things. Otherwise, you're hitting a push to talk button all the time and all that. With the microphone on single sideband, it's really important to have a microphone that is adaptable to your voice and the way you like to operate. So it's important to have a microphone that, and especially the modern radios, allow you to tailor the sound. They will have equalizers built in to be able to adjust the frequency response. But there are some microphones that are better for the application than others. Like, for instance, a studio microphone, let's say a high fidelity studio microphone, might not be the best thing to use for amateur radio, at least for single sideband, because it's just too wide a range. Single sideband, you want to focus on the elements of speech that carry and convey information when you're talking. And so it's a very narrow band. So there are microphones that are called communications microphones that are designed specifically for that. So there's some other things you want to look at. Of course, the mic gain, the mic level is important. You don't want to have the level too high because you'll lead to distortion. Compression is another thing. Speech compression in a radio is very useful because it increases what we call the average power, the average talk power, output power of the radio, because your voice level varies a lot from high to low. What a compressor does is it brings that level up and maintains it at a fairly constant level. And that's useful because it makes you get heard better over the air. Your voice will stand out when you're using compression, especially in a contest. And working DX, if you're doing that, compression is a useful thing to have. And most modern radios have built-in speech compressors, so important to know that. And I mentioned about additional audio settings for transmit, like equalization and things like that. And the point here is using another ham, or listen. Anthony mentioned the web SDRs. Listen with a web SDR. And what's interesting about the web SDR is if you listen to yourself live, you're not going to get an impression of what it sounds like. First of all, there's a delay because it's on the internet, and there's a lot of processing going on in that signal to get to you. So there's a time delay. So you're going to have a hard time listening to it live. Most of the web SDRs have a recording function, and that's what I use. Is I just record my speech, record the transmission, then I go back and listen to it later to see what it sounded like. And then I'm not listening to it live, and it makes it a little bit easier to do that. We'll talk about splatter. If you're overdriving the radio, if you've got the gain too high, or you're using an amplifier and overdriving the amplifier, you start generating all types of spurious emissions. And in particular, we talk about splatter, where instead of being this nice, tight, single sideband signal that occupies 2.5 kilohertz, you're now occupying 10 kilohertz because you're splattering and overdriving the radio. So splatter is and there's a good example of it on an SDR waterfall, what splatter looks like. All those little edges sticking out to the side there on that right-hand image. That's splatter. And that's not being a good ham neighbor if you're splattering. So that's a good one. Clean, punchy, competitive contest audio without splatter. That's getting the mic level set correctly, getting the compressor set correctly. It's a good set of information. And it's not your microphone, it's you. Steve Katz is a pretty outspoken guy, does a lot of presentations. And Anthony's linked the one it's not your microphone, it's you, from Steve Katz, WB2WIK. We're trying to get him to come on Rat Pack. I haven't been able to contact him, but he just recently moved. So let's see what's next here. I think that's you're up now, Anthony. It's your turn.
It would help if I unmuted myself.
There you go.
Thank you, Dennis. Components of the HF station include the antenna, which we mentioned, and probably the simplest antenna to get started with is an HF dipole. It's a quarter wave long on each side, so it's a total of 1/2 wavelength in total length. It has an insulator in the middle, insulators on both ends, and the key is you have to get it up in the air. Having it on the ground is not that great, or in your basement like I had mine. But you can also set it up as an inverted V with one center support if you don't have two supports, and that also gives you a more uniform pattern of distribution also with an inverted V. So it's no problem if it's hooked up as a dipole or an inverted V, basically the same antenna. To give you an idea of the sizes, on 20 meters, it is approximately 16.6 meters long. And it varies a little bit if you're on either end of the band. So you notice the difference from the low end of the band, the CW portion, it's 14.10. In the middle of the band, it's about, that is in feet, I'm sorry, 14.10 meters on the one end and 14.35 on the other end. Oh, I'm sorry, those are the frequencies. Let me start again here. This is at 14.10 on the low end of the band, it's about 16.6 feet long. And on the higher end, it's about 16.3 feet. So it's not a big difference in that particular band. Now, when you get down into the lower HF bands, it becomes very significant. So the dipole antenna at the low end of 160 is about 130 feet long, whereas at the high end, it's only about 123 feet long. So a difference of about 2 meters in length.
Anthony, let me make a point on your table there. Those lengths in feet are the quarter wavelength.
Yes, from here to here.
From one half of the dipole. So the dipole would have 2 of those. So on 160 meters, it's going to be almost 100 meters in it's going to be half that, 80 meters, right, in length. The dipole will be 80 meters in length, roughly. So just to make that clear. So it's a big antenna.
But there's a ton of different antenna types out there, a wide variety of wire antennas. We already talked about the dipole, and it can be installed as an inverted V, but it also can be end-fed, or it can be an end-fed half wave. It can be an off-center fed. It can be a sloper. It can be an inverted L where it goes up and then across. You can make antennas out of feed line. These are more common at VHF frequencies, but you can make them for 10 meters very easily. A J-pole, a bazooka, a flower pot antenna. These are all antennas use feed line as part of that half of the antenna. Every antenna has 2 halves to it, whether it's a dipole with 2 halves, or whether it's a vertical where one half is the vertical and the other half is the ground, or the radials on the ground. So every antenna really has 2 components to it. Illuminant antennas can be either verticals or beams. Hybrid antennas are things like the cobweb antenna or the hex beam. You can have loops, both horizontal loops, vertical loops, and then you can also have something called a compact transmitting loop, which are often referred to as magnetic loop antennas. Although they're not strictly really magnetic loops, the best way to really accurately describe them is compact transmitting loops. And for all these different antennas, I always get questions: what is the best antenna? Is this antenna any good? So HF antennas are subject worthy of multiple presentations and sometimes very heated discussions. We can only scratch the surface today. The size and complexity of putting together supporting and erecting and feeding an antenna, any local zoning, leases, leasehoods, freeholds, agreements, restrictions can dwarf the other aspects of getting on HF. So this is really the point where a lot of people get stuck with getting on HF. Buying the radio is very simple, but sometimes putting an antenna up that's going to work outside can be very difficult depending on your situation. Don't let that stop you. There's a lot of ways around this. Stealth antennas, smaller antennas which may not perform as well but still get you on the air. So understandably, antennas can be the downfall for hams just starting on out on HF. There's a lot of exaggerations and misinformation out there, in person, online, written material, commercial hype, etc. There's way too much anecdotal evidence based only on a casual personal observation. You'll see an advertisement for an antenna that says, I worked blank with this antenna. I worked South Africa. I worked Europe. I worked Czechoslovakia. I worked whatever. And it's really meaningless because they're not telling you what band, they're not telling you what the propagation conditions were. I've worked almost everywhere with every antenna, but it doesn't mean the antenna worked well. The other thing is many of the issues are the result of trying to avoid a number of things. The things that most people are trying to avoid are large size. Large size can be a problem as far as erecting and keeping the antenna up in the air. It can also be a problem of personal dislike by either a significant other or a neighbor or someone else that doesn't like your large sized antenna up. Keeping the antenna in the air, as I said earlier, support and erection issues can be difficult. If it's a vertical, it sounds like it might be very simple, but you need radials in most cases. You need a counterpoise of some sort. And there's always this urge to try and get rid of those to make it easier. Also, undesired visibility. Let's make it thinner, smaller, different size. And there's required effort. You have to assemble the antenna, construct it. You need to do proper installation. And if you try and skimp in any of these areas, you won't get good performance. So here's an example. This was found on the internet. You could buy this. Unfortunately, it's not currently available right now. I'm sure it'll be available soon again. But this is the Miracle antenna. You can hold it in your hand. It has a whip that extends out. The whip length when it's spread out is 1,710 millimeters, not centimeters, millimeters. And you plug in your radio here, and then you tune the radio all the way from 160 up to 6 meters. And that's all you need. You don't need any counterpoise. Well, you really should put a counterpoise in this little plug down here. They don't really talk about that a lot, but you should run a counterpoise out of this little plug for maximum performance. Now, I have made contacts with antennas like this, but it won't be your be-all antenna. This is actually advertised from 0.6 megahertz all the way up to 460. It probably works actually much better at 460 megahertz than it does at 0.6. It has 30 to 40 dB gain over the HF 30 to 40 dB gain on receive over a plane whip. Now, what's the plane whip standard? I've never heard of that standard for measuring dB. dB is actually measured versus a isotropic antenna, which is a theoretic antenna, as opposed to a plane whip. And it's engineered for these radios. These are all low-powered radios. Its exclusive auto transformer tuning is a unique effect. And I'll tell you, this will work. You can make contacts on it, but it's not going to be a consistently good performer out there anyway. So a couple years ago, at the beginning of COVID, a lot of people in the US were not able to put on club field days like they normally would do. And a lot of people decided they were going to do field day from home. So I started out by putting together this little sheet called tiny.cc port antennas. I'll bring it up here with the link. And this is a sheet that I put together comparing different types of antennas, pros and cons, mainly for use for people for their personal field day. But then what happened with any project I start, it got out of control. And it actually has sections on all different types of antennas, both commercial and homebrew versions of half-wave dipoles, non-resonant dipoles, resonant, non-resonant ED-FEDs, inverted Vs and slopers, verticals, beams, stealth, and indoor antennas, 160 meter limited space antennas, magnetic or compact loop antennas, integrated antennas such as the rubber duck and backpack whips, pedestrian mobile staff such as the buddy pole, mobile antennas for your vehicle, VHF, UHF antennas, and then a whole list of general antenna resources, and then a little guide from the Villages. The Villages is a retirement community in Florida. And one of the big things they do is they have a lot of members in their club who live in areas that have deed restrictions on the property. So you're not allowed to have antennas up. So they've come up with ideas for how stealthy is the antenna? How well does it work on the air? How much is it? How difficult is it to install? What is the cost like? Which bands is it good on? They give it an A through F rating on each of the different bands. And it's just a little chart that I find very useful if you're looking for stealth or hidden antenna use. So that whole thing is available at tiny.cc/portant, portable antenna. And I got this all zoomed out of whack here, so let me fix that real quick here. Okay, there we go. We're back to normal. So this is, excuse me, this is my antenna farm. My property is approximately about 25 meters wide by about 50, 60 meters deep. And I have luckily squeezed out enough room to put in a 50-foot tower here with a 3-element log Yagi antenna. So you actually see more elements, but typically on each of the bands from 20 through 60, there's 3 elements active at a time, and it's a 30-meter rotatable dipole at the end of it. Coming off that, I have a 80-meter sort of boarded towards Europe, and then I have a 100. This wire is 60 foot long, about 20 meters long. This is a 160-meter sloper with a small loading coil in it. Comes almost down to ground level at the driveway. Now with my 5 watts, I've worked 86 countries with this sloper, a 160 in all 50 states. Hidden in the tree that you can't see here is a 43-foot random length vertical from DX Engineering with an antenna tuner at the base of it. So that's what I'm using for all my operations, and you saw my performance before in the CQ Worldwide. So the big thing to note is if you work a lot of contests, the stations on the other side have great receive antennas. So if you can get out any signal at all, you're going to have a good chance of operating on multiple bands. I like to use Google Maps a lot because when I travel and do portable operations, a lot of times I don't know what I'm going to be able to put up antenna-wise. So before I go there, I look on Google Maps and try and figure out where can I put it. And by the way, these measurements come by right-clicking on Google Maps and say measure, and you can measure the distance on the map accurately. So that's how those are there. Before I jump into feed line, I just want to mention one thing. I always get asked, what is the best antenna? And I always tell people, I can't tell you what the best antenna is, but I can tell you 4 of the worst antennas. The 4 worst antennas, the worst of all is no antenna at all. The second worst antenna is an antenna that you purchase and it's lying either in your house or in the garage, unassembled and disconnected. They don't work very well. The next one is an assembled antenna that's not been installed. That doesn't work very well. And then unfortunately what happens, a lot of people put a lot of effort into assembling the antenna and actually installing it, but they don't do a good job of either assembling it, they don't assemble it properly, or they don't install it properly. And then some people get all that right, but then they get to the last step of the feed line and they use poor feed line to feed it. So those are the worst antennas that you can have. Definitely no antenna is definitely the worst one.
That's the worst.
And it's only slightly better to have an antenna still in the box.
That's funny. That's good, Anthony. Well, now you got your antenna. You got to feed that antenna. You got to get the signal from the radio, from that transceiver or your antenna tuner out to the antenna. And that's where the feed line comes in. Most common thing we use is coaxial cable. Coaxial meaning that there's a conductor, a center conductor with a shield around the outside of it. And that runs the length of the cable. It has what's called a dielectric between the center conductor and the shield, and an outer jacket around it to protect it from the elements. So that's our typical coax cable. And typical impedance, that's the stuff we typically use, is 50 ohms, 52 ohms. That's the nominal impedance of most of our radios that we use is 50 ohms. So we use a 50 ohm coax. Now 75 ohms is also very common and is used for cable television and also for hooking up interconnecting video equipment in studio and in home. 75 ohms is used for video. believe it or not, there's no problem using 75 ohms. I'm going to talk about that in a little bit when we talk about impedance matching and SWR, but 75 ohms is, if you have 75 ohm cable, by all means, you use it. It will work just fine. But there's other types of cable that we can use, and this is what we call like a balanced conductor, or a twin, as he has there, a twin feed line, open wire window and TV twin lead. And there's examples of those. So open wire, or what's always been called ladder line, because it looks like a ladder, is two conductors separated by a bunch of insulators. Now, this is a very interesting type of feed to use because it's not dependent as much on frequency as the coax type antennas are, or the coax feed line. If you have a resonant antenna fed with coax, that antenna is going to be very susceptible to changes in frequency as you move to other bands. But if you have a doublet or a dipole that's fed with ladder line, it tends to be an all band antenna, and it doesn't have those same problems that that you'd have if you were feeding it with coax. So ladder line's useful. It is heavier, it's tougher to deal with. You have to have something to match that to your radio. You have to go from that balanced feed to the unbalanced coax. So you have to have something called a balun, or some type of a tuner that does a balanced output. So TV twin lead, the 300 ohm TV twin lead, we've used that for decades for our home televisions. And that can actually be an effective feed line, but it's lossy because of the insulation on there. So somebody came up with this idea of what's called window line, where we cut out big chunks of it so it maintains it mechanically as twin lead, but it's got big holes in it, so that it's not as lossy. And it really would be lossy if you happen to be in an area that has a lot of snow and ice. The twin lead is not a good solution, but the window line does work better if it's wet or icy. So that's those are common things to use. The window line and coax, of course, is the most common. It's also the easiest thing to use. It's very simple. Coaxial cables come in all types of varieties, as we say, different diameters, different types of insulation or dielectric materials, different impedance, different loss, because naturally, because it's a cable, it's naturally going to have loss, and the loss increases as you go up in frequency. So it's important to know what frequencies you're operating at and what you're going to use. Power handling is a big one. You don't want to be using something like a minuscule RG174 running hundreds of watts. RG174 is very tiny. The RG8, which I mentioned earlier, RG8U, LMR 400, the other RG213, RG214, these are great for running high power. I can run legal limit here in the United States, 1500 watts through any of those cables without any trouble at all. So that's power handling is important. Some of the other cables like RG8X, which is another 50 ohm cable, but it's a smaller diameter, really is not good for handling high power, but it does okay. You know, if you're running a couple of hundred watts, no problem at all, and it's very easy to work with. Ultraviolet resistance is important because this is going to be outside and it's going to be in the sunlight. So UV resistant, it's important that the cable be UV resistant. And there are versions of these cables that are designed for direct burial. Some coax you can direct bury, it's designed for that. Others, if you bury it, it will eventually rot the plastic out. So I talked about this earlier, 50 ohm versus 75 ohm. 50 ohms is typically what we use for ham radio, but 75 ohms is used for like cable. I mentioned cable TV, video, those types of things use 75 ohm cable, and that will work. That will work just fine. It'll have a little tiny bit of loss, but not enough to amount in anything. So we'll see that in a minute. Quality is important. I have some direct experience. This is my own anecdotal information, my anecdotal evidence. I picked up some RG8X off of Amazon recently, and the stuff was just junk. It was rubbish. It was impossible to put connectors on it. It did not solder. Putting crimp connectors on it was horrible. It was just terrible. And so I got what I paid for. Companies like DX Engineering, buying from a reputable dealer like DX Engineering, you get good high quality cable. They have a couple of different manufacturers that they source, and well, I'll tell you, that makes a big difference. The age is important. Exposure to the elements. One of the things that with coax that can be bad is if you have an exposed end, or you have a connector like a UHF connector that has not been protected against the elements, against weather, you get moisture into the coax, and the coax will degrade because the moisture will migrate up into the coax through the length of it, and it will ruin the coax over time. So if you live in a very wet environment, you have to make sure everything is well sealed against the weather. Here where I live in the desert, it's not so much a problem. I don't worry about it that much, although we do get rain. We've actually had a total of a ½ inch of rain in the last couple of weeks, which is a miracle for us. We never get that. So, but you know, sealing up the antennas with various types of materials is a good thing to do. Again, I mentioned this mishandling with overpower, too much power in the coax, it will melt. Kinking the coax can actually short it out. They'll talk about what's called a minimum bend radius for the coax. So you don't want to exceed that bend radius, go any smaller than that, because what happens is that the center conductor will actually be displaced in the dielectric insulation, and it can touch the outer conductor, the shield. So you ruin the coax. So you got to be careful of that, kinking it. So this is a table. It's a table that if you look at this thing, okay, there's a lot of information here, but the thing to take away from this is the various types of coax. And I mentioned RG174 at the start because it's very tiny, which is kind of desirable if you want a stealth antenna. If you're running QRP, it's great for that because it's very compact, it's very portable, but it's lossy. And as you see, as you go up in frequency, look at the loss for the factors here. And this is in dB, 2.3 decibels, and that's per 100 feet, 2.3 decibels at 1 megahertz for RG174. So you're typically not going to use that for a long antenna run, even for HF. 58 is inexpensive. It's a good at, you know, if you get it from a reputable dealer, it's quality material. It can't really handle a lot of power, and it has a little bit of loss. RG59 is 75 ohms. That's your CATV stuff. So it's going to have some loss as well, but it's a little bit larger diameter than the RG58. So it's not quite as lossy as the 58 at certain frequencies. RG8X I mentioned, that's a recent addition in the last 20 years or so, a relatively new product. And that's very, very commonly used. If you're running a 100-watt station, it's great for that. If you're running higher power, you need to have something that's a little bit larger diameter. We got the RG213, RG214, and these are great. These are what they call a double shielded. It has a double braid shield on it, so they're very noise immune, which is useful. They're not so lossy, not lossy at all. The 214 and 213 are great. I use a lot of that. LMR 400 is expensive stuff. It's a lot more costly. It's very stiff and hard to work with, but it's very low loss. And 9913 is really great stuff. These are all, those last four are all considered like a ½ inch diameter coax. So those last four, if you want to go with the best, those last four are the way to go. But it's gonna be dear. It's gonna cost. So RG8X is great if you're starting out. That stuff is great to work with. The connectors are easy to install. You can even get them pre-made. You don't have to install them yourself.
And spend your money on these more expensive cables if you're operating in VHF and UHF.
Yeah, that's right.
You know, if you're operating 40
especially
meters, you're going to be just fine with any of these cables in this row.
Yeah. Except for the 174. If you're running any great distance and you're running 100 watts, you don't want to use that. That's not going to work.
This is for 15 foot and under is what I consider useful for.
Yeah, it's useful for being, if you're portable QRP, it's great for that because it's extremely lightweight and very compact. It can be coiled up very tightly. Connectors. So I mentioned connectors, and you can either get these cables pre-made or you can install them yourself. They're not that difficult to install, but the PL259 is probably the most common connector we run into, and it's referred to as a UHF. And I like this. Yeah, it's a misnomer because it's typically not used but VHF. And it's called a UHF because when they were designed and invented, that was UHF, 2 meters, 100 megahertz, 100 megacycles in those days was considered a high frequency, ultra high frequency. So that's why they were called UHF connectors, but they're useful to 2 meters without too much trouble at all. They work fine all the way up to 2 meters. BNCs are great for portable, for low power. They're a bayonet type connector. They're waterproof, which is nice. So the weather can't get into them. Common on test equipment, especially, or interconnections in your ham shack. I use a lot of BNC connectors in the ham shack, but very much used on portable and QRP rigs extensively. So that's one to be a little bit tougher to install than a UHF connector. SMA connectors, we typically don't use those at HF. They're typically would be used on a handy talkie, and they're used UHF and microwave is where they find the most common application. But you will find things like some of the little, the inexpensive SDR receivers, if you happen to have one of those, might have an SMA connector on it for HF. So that's something to watch out for. But SMAs, we probably won't use those that much. And they use a very, very small diameter coax like the 174. End connectors. End connectors are great. They're good all-purpose HF to UHF and above connector. They're good out to like 18 gigahertz in frequency. They are waterproof if they're installed correctly, and they can handle a great deal of power. So those are great, but they're a little bit more difficult to install if you install the old style connectors. With the crimp-ons are easy, but the older style ones are a little more difficult. And of course, the F connector is used extensively for cable television and video and things like that. And I know in the UK, I'm not sure what they're called. I know you use a connector that's kind of like an F connector, but I'm not sure what they're referred to as, but it's kind of a push-on equivalent of the F connector for cable television and things like that. So I actually have some of those in the shack here that I use. So I'm familiar with those, but I don't know what they're actually called. Yeah, the installation varies with the type of connector. A lot of the connectors like the UHF, the PL259 is a solder connector, but you can also get versions of that are crimped on, that are very easy to install and very durable as long as they're done correctly. Solder, when you solder one of these connectors, it's got a bit of a mass to it, so you need to have a fairly high wattage iron if you're going to solder a PL259 connector. I have a 75 watt iron that I use when I assemble soldered connectors, just to get that braid to the shield braid to solder, get it connected to the connector itself, because there is some heat mass there. There's lots of information online, and Anthony's given us some links to be able to install connectors on these different types of cables. And it like I say, once you get the hang of it, it's real simple to do it. You just have to be careful, because you're probably going to be using something like a sharp X-Acto knife or such when you get started to cut the insulation and things like that. So you got to be careful you don't cut yourself. Eventually, if you really get into it, you can buy tools that actually do it for you, which is nice. Little tool sets that will strip the insulation off and cut the coax, or cut the shield, cut the center conductor to length, and make it all perfect. So you just slide the connector on and crimp it or solder it. So those are things to be aware of. But yeah, follow those links to get the information on that. And I totally agree with Anthony on this. No shame in buying coax with pre-installed connectors, but make sure it is high quality. Again, DX Engineering, I have actually purchased pre-made cables. Me, who makes everything, I have purchased pre-made cables just because it was easier. And they're very good cables that I got from them. I can't think of the name of the company that manufactures them, but I use their coax and I used some of their pre-made cables, which is good. So, oh yeah, pre-made cables. If you're going to enter your home, means you're going to have a bigger hole for the coax to go through. If you install the cable, once you get it into your house, it only requires a smaller hole. So that's something to be aware of. And on that topic of getting the cable into your ham shack, this can actually lead to a lot of other information that we need to share. And we've got some talks on this that I think Anthony may have one. I know we've got some stuff on RatPack that you're going to want to look at, because it's really important when you bring the coax into the shack that you do this correctly. for safety purposes. And this is for lightning, especially if you're in an area that's prone to lightning, you want to make sure you take care of that. So this bulkhead panel, and you see some versions of this. The one in the lower right is kind of cool because that's like a non-invasive type panel that you can put in a sash type window that it just goes in there, and you close the window down, it lock the window in place, and you've got a coax entry panel that brings everything into your home, into your Radio Shack. So those are useful. I do something like kind of like the one that's on the lower left there, where I actually have a closet on the exterior to the ham shack, where there's an aluminum rather than copper. It's an aluminum plate that I have these little boxes that you see on there, which are lightning arresters and static discharge devices to protect your equipment. I have all of those bolted down to that plate. And so that's where everything comes into the ham shack through that closet into the Radio Shack, and then it gets distributed out to all the different positions from there. That's your optimum. That's really the top of the line way to do it. If you want to go over the top, that's the way to go. These entry panels are great. I have used a clothes dryer vent. I've used that as an entry. The problem to be aware of that is what I'm talking about with lightning protection. Make sure that you have it adequately protected before it gets into the house. You want to keep any kind of lightning discharge, electrical discharge outside. You don't want any of that stuff coming in. So it's very important to do that. And like I said, there are talks on that are Anthony, I'm not sure. Do you have a talk on that? Do you do a talk on
No, but the Ward Silver one is probably N0AX is probably the gold standard on those.
I agree. Yeah, Ward, if you're familiar with Ward Silver, he's an author, does a lot for the league. The ARRL is published at QST and has published several books. Grounding and Bonding, his book, is without doubt that is the de facto standard for doing this. He's been on Rat Pack. We've had him on there as a speaker a couple of times, and he's done a great job of describing all of this. So these are all good.
And the last one here, this temporary one,
Sure.
this is something I would not recommend for long term, but because
Right.
I do a lot of portable operations from different people's locations, I found that pool noodles, those foam split pool noodles, will allow you to close a window down without crushing the coax, and they also work vertically on a sliding door entry. So
Yeah, that's true.
pool noodles can be very useful for portable use, but I wouldn't recommend them for your
Not for permanent setup.
use.
Yeah. So antenna tuners, and like we say, it doesn't really tune the antenna. One of the things I mentioned early on is that your station is a system. And the system consists of an antenna, your feed line, and your radio. And to get the optimum performance out of your radio, all the impedances need to match between the transmitter and the antenna. You need to have this thing tuned as a system. So what we're really talking about is matching the impedances between the transmitter and the feed line and the antenna rather than tuning it. But they do get referred to as antenna tuners. It's a kind of a just what the word that's stuck, but it's really an impedance matching device, and they take all different forms we've got several of different versions here. One we've got on the left side is a manual tuner where you actually tune it yourself, watching the meters for getting minimum SWR, which means that you're getting the most power out to the antenna. The one in the middle is an automatic tuner that's weatherproof, and you might use that for an automobile, or again, I've used one like that for portable operation for things like you hook it up to a vertical temporarily when you're portable, and it can sit outdoors, but you could just as easily use that with a permanently installed vertical and put that at the base of the vertical and use it as a tuner for that. And it's weatherproof. The little LDG there is a little automatic tuner that might go with a QRP rig, like an 817 Yaesu or something like that. That's what that's designed for. So these are all the different types of antenna tuners. So I mentioned automatic and manual. So an external tuner, your typical radio, if it has a built-in tuner, may have a range of an SWR of 2-to-1, maybe 3-to-1 at max. So if you have a really bad mismatch, an external tuner is the way to go. And you can get one that will do up to 10-to-1 or even higher SWR ratio than 10 to 1. There are tuners that are manual, so you have to sit there and spin the dial yourself, which is relatively easy to do. Automatic tuners are great. I've got a little bit of both here. There's an automatic tuner up here for HF, and then these are manual tuners. I've also got another one over here that's a manual tuner it's up on top of the cabinet there that I use with a horizontal loop that I've got out on the side out here, a 160 meter full wave loop that I have a balanced tuner to drive that. That's also manual. But this guy is fully automatic and can handle legal limit, which is wonderful. Also, I mentioned the idea of remote mounting it at the antenna is also a good way to do it. It really cuts down on feed line losses greatly. So that's one way to go. And we said that most modern radios do have built-in automatic tuners, and those are the 3 to 1 is the majority of those. And I don't know if any that do 10 to 1. Maybe there are some.
The Elecrafts do.
They do. Okay.
Yeah, the K3 does it. The K3, the KX3, and the KX2.
Yeah, that's going to be a lossy. That's going to be pretty lossy at the 10 to 1 though, and an internal tuner because of the way they're designed. But that's cool. Okay. So yeah,
these are all links.
All the links. How does an antenna tuner work? Yeah, do some research on this and understand how this works. But yeah, this is some good information on antenna tuners, more than we could ever cover in a presentation here. So yeah, the links are great. SWR, I mentioned this earlier. And how critical is it? We're talking about, well, 3 to 1, 10 to 1, all of this. What does standing wave ratio actually mean? Well, it's the ratio of our power in to power out. So power going into the system to the power that's actually getting to the antenna that we can radiate. That's our standing wave ratio. So it's a ratio of it's actually the power, what we call forward power versus the reverse power, or stuff coming back. Because when we have an impedance mismatch, we get a reflection. The signal's reflected and it comes back down the feed line. So that's the SWR is that ratio of the power, what we send forward to what comes back from the antenna. And our VISWAR, which is measuring the voltage rather than the power, it's the voltage ratio, VISWAR. So there are a lot of misconceptions about this. We think of it, oh, I got to have a 1-to-1 SWR or it's not going to work. Well, it doesn't have to be. And you'll see as we talk about this that if the SWR goes up, yeah, we're going to lose some efficiency. That's the downside of it. The thing you have to be careful of, and that's why we would go to a tuner, if the SWR is too high and we're getting too much power reflected back into the radio, we can actually damage the radio. We can damage the power amplifier, the PA section of the radio. So that's sort of that if it's over 2 to 1, I'm going to let the smoke out of the finals, but that's not necessarily true. If you look at this chart, let's talk about a 2 to 1 SWR. If you see there in the white section, 2 to 1 SWR, the percentage of loss is only 11.1%. So if we're putting 100 watts into that feed line, we're only losing 11 watts. And if you put that in perspective, of what what is that in terms of S units, is virtually undetectable. The person at the other end would not know the difference. If we talk about, let's see, if we get up to a half power, so we're losing half of our power, 51% with an SWR of 6 to 1. That represents roughly a 3 dB loss, okay? Because half power, 3 dB. An S unit is actually technically defined as 6 decibels. So if you had a 6 to 1 SWR ratio, you're only going to lose half an S unit. And so this kind of puts things in perspective. But I would not really want to be running a 6 to 1 ratio with my transmitter. I would want to have something tuner in there. I'm not so much worried about the radiated signal. I'm worried about my transmitter itself and damaging the transmitter, which is why I would have a tuner, always a coupling network of some type. So you can see like 1.0 to 1, 0 loss, 100 watts in, 100 watts out. So that 1.0 to 1 to 1.5 to 1, that's the sweet spot where everybody wants to be. But you can see from the table that it's not necessarily so. That if you can protect your transmitter by reducing the SWR, that's good. If you have a mismatch, and that's the whole idea of using the tuner, is that between the transmitter and the tuner, my SWR is going to be down to 1-to-1. Between the tuner and the antenna, it's going to be whatever it was before. And even if it's 6-to-1, I've got a match because of my tuner, but I'm only losing half my power. So that's an aspect to consider, and don't be as worried about SWR as people tend to be a lot of times. I will tell you from personal experience, I have one of the pieces of equipment I have behind me here is an alpha amplifier. And this is an automatic tuning amplifier. And it is sensitive to SWR. If I have an SWR of more than 1.2-to-1, the amplifier will shut down. It doesn't want to run that way because it doesn't want to damage the amplifier. So I always have a tuner. I've got a tuner between the antenna and the amplifier to keep the SWR below 1.2-to-1. But I'm not as concerned about the losses in the system. I'm more concerned about that reflected power back to the amplifier is why I do that. And the amplifier would fault. It would actually just shut down. So Anthony, I think that's back over to you. Yes?
Yeah, it's back over to me because that's the end of our talk for today. And I have, let me get past this. This is the link for today's presentation, tiny.cc/UK begin HF, UKBGHF. I know that's a horribly long word, but that's what the shortener gave me. And that will get you access to all of the materials from today's talk. And you can also, once you get there, if you need a PDF, you can click on this link. But remember, that'll give you the frozen in time. It won't have any of the updates. We're going to do week 3 next time. And week 3 is going to consist of setting up your station, HF challenges, computers in the shack, and basically what else. So those are the topics we'll be covering next time. And again, if you go to this link, you can read the topics ahead of time if you want to. I'll put the links in the chat for the presentation, and we'll be happy to take questions that anyone might have. I'll go ahead and bring down the screen sharing. And by the way, when Dennis was talking about the SWR, if you go back and look at the SWR table and then you go back and look at the coax table, you can see by using the wrong coax, you lose a lot more power than you will by having a 3-to-1 SWR.
Right. Yep, that's true.
Well, brilliant, Anthony and Dennis. I sat watching it as someone who's played with radio for years and years and years, and you suddenly think, goodness me, don't we do a lot of things in this hobby? Isn't there a lot going on here? It's I mean, before I just chuck it open to questions and comments from people in the audience here, I think you can make radio and amateur radio as simple or as complicated as you like, can't you?
Yes, you can.
We can have a fantastic amount of fun with, for example, a 5-watt CW transmitter with maybe 2 or 3 semiconductors in it, and we can make contacts with it and be just utterly amazed we can do it. But equally, of course, we can have fantastic fun with the most complex modern radios that do all kinds of things that very few of us could dream about building something of that complexity.
That's very true.
And I mean, I think probably the truth is, for probably everyone in this audience, including yourself, Anthony and Dennis, and definitely including myself, we all play with different aspects of things, don't we? So we can jump from very complex to very simple. I don't think my shack is anything massively complicated, but on the occasion when I have to take things apart because something's gone wrong, and I look down at the wires behind it, you kind of wonder, how on earth did that go in? And
very true.
My dad, who's now Silent Key, was a radio ham, and when he passed away, not his radio equipment, because he gave up amateur radio in his last years of life, but his audio and TV stuff, we were just massively blown away with the complexity of the wiring that he was running behind his TVs and behind his record players and so on. Good. I mean, my brother and I were struggling to work out what on earth half this stuff was actually doing.
We call it wireless, but it's definitely not wireless by any means. And the only thing that exceeds the number of wires is the number of adapters you need for the different cable connections. I didn't include it in the chart for coax connections, but on my Argonaut 515, the antenna jack is an RCA and the power jack is an RCA. So if you don't know how to know which one you're dealing with, you can easily plug 12 volts into the antenna jack.
Those RCA jacks were very common on vintage gear back in the day. In fact, all this gear sitting in front of me here that you saw early on has just lots of RCA connectors on the back. I was going to make a comment, Nick, your comment about the cabling. Modern radios are great because they don't have all the cabling that the vintage gear. There's probably 30 cables in a cable tray behind my radio here in front of me on the desk, tying the amplifier and the transmitter and the station control and 2 receivers and the speakers and power meters and all this stuff, tying all that stuff together and tying it into the computer and all that. It's a rat. This one isn't actually a rat's nest. It's actually very clean because I have it in a cable tray and it's all sealed up so it looks really pretty. But what's inside that cable tray is a mess. But that's the vintage. That's what happens with vintage gear.
Right. Well, let's chuck it out to the audience. And who wants to go first with a question or comment? Everyone's gone very quiet now.
Oh, don't all speak up at once. Come on.
Yes, come on, Keith.
I'll put the mic down. You can probably hear me. Can you hear me all right? Yeah, jolly good.
Oh, yeah.
Yeah, a couple of things. One, we probably all know about it anyway, but as this was for beginners, voltage drop. I did have last year problem with my transceiver. It received fine, but it wouldn't go into transmit. And after a lot of head scratching and a quick phone call to Martin Lynch, because I was at the end of my tether, it turned out that it was dirt on the fuses, the car type fuses in the fuse holders. And I thought, I checked everything except those. And of course, fiberglass stick on the edges, plug them back in, 100 watts straight out. So for those that are unaware of that one, that's just a little reminder. So be careful.
I had the
of those.
exact same problem with a friend. He had a Yaesu FT891, and that was exactly what the problem was. The fuse holder. He used it a lot in the field, and the fuse holder had became dirty inside there, and it was not making good contact.
Like corrosion or just dirt?
It was more
just
dirt.
Yeah, well, mine was tarnished. Mine's an FTDX 3000, but yeah, it wasn't that good. And the other thing that I was going to add was on cables, coaxes, I use Ultraflex 7, which is quite a nice little cable. And what I do like is the fact that when you buy the connectors on the back of the pack, it shows you how to connect them.
How to install it. Oh, that's beautiful.
How to install it, yeah. So you've got these beautiful waterproof connectors with, put it in the right place. I've not got a very good camera, but it's a step-by-step how to actually
very nice
connect it.
You call it, that's Ultraflex 7?
It's Ultraflex 7, yeah, and the cables are Messi and Paolomi. They're Italian.
Okay. Yeah. Okay, those are the guys that make the what is that? It's the I can't think what it is. It's the cord. Isn't that the company that makes the antenna cord, the antenna rope? What's that called?
It could well be.
I think it is. Yeah. Very interesting.
But the advantage is it's a smaller diameter than the 213 and 214.
Okay.
And it's a lot more flexible.
Interesting. Well, one of the cables that I do use is the Times Microwave LMR 400 Ultraflex, which adds about a 100% premium to the price of the coax over the regular LMR 400, but it's extremely flexible and it's very low loss. I really love that, but it is dear. It's very expensive, but that's good stuff. That's very cool. I'm going to check that out. I'll check that
What
out.
what Messi and Paolini make as well are those fantastic compression PL259 plugs, which what Keith was demonstrating there was how you cut the cable to fit exactly into the plug. But then, of course, you know, you're joining it together essentially with a compression fitting.
Yeah,
You do up with a spanner. And when I discovered them, I was so pleased, because soldering PL259s is one of the worst jobs that we do in amateur radio, in my view.
yes.
I've gotten pretty handy at it. I've been doing it long enough. I'm not going to mention since 1969. It's become kind of second nature, and for many years I always did it with an X-Acto knife, cutting, you know, the little handheld hobby knife. And I finally discovered the coax what they call coax prep tools. And so I've got a whole set of coax prep tools that cleanly cut the insulation and the jacket and the dielectric, and cut the thing to the right length for the type of connector that you're using. And so I love the crimp-ons. They're so easy to deal with. I've got a lot of coaxial fittings in this. You can't really see the backside over here, but there's dozens and dozens of cables. You can see all the switches that are here. There's more switches up there and more switches down here. There's just tons of connectors. So okay, yeah, nice. So that's like the compression. That's like the old style. The old style type N connectors were a compression.
That's right. Yeah.
Actually, compression fitting with a soldered center pin. Yeah, I've used a lot of those. And the BNCs as well. They are. I have to admit, it's a pain in the neck to use the compression fittings, like the old style end connectors. I'm going to check into this. This looks interesting. Was not aware of that.
There are available. I see DX Engineering carries some of their stuff in the U.S.
Oh, good. Okay, cool.
By the way,
What I also like, the black ring here for the final connection is actually a rubber O-ring. So it's completely waterproof.
That's your weather seal. Yeah, that's nice.
Yeah,
that's excellent. See if I got.
we could add that to our Christmas gift list. By the way, for the Rat Pack, if you're looking for Christmas gifts, if you go to the Rat Pack site, we have our listing. Last week we did our Christmas gift list, and then I did an addendum afterward for ideas for getting youth involved with radio. So I'll put the link in the chat for that presentation. Actually, I'll put the link in for Rat Pack, and then you can look it up on the Rat Pack list, because that way you'll get an access to all of our presentations.
I was looking to see if I
did that right. Oh, let's try that again.
But I don't have one handy. I've got a rack full of coax jumpers out in the back room. I'm not going to go out there and grab one, but I do like using the crimp connectors, and you make them waterproof with heat shrink, which is really nice. There's a gel that you put on there, and then put the heat shrink over it, and that makes it a waterproof connection. I love those for the end connectors. The end connector,
try that for the third time,
is by design is a waterproof connector. So the crimp-ons are nice for that. What are you bringing up, the Christmas list?
This is the Rat Pack list.
The list in general, yeah.
Yeah, this is the list in general. So if you go to this list, there's 250 slideshows recorded, the video presentations of each of the slideshows. And if you go back to number 251, which was on December 7th, that's the one we did for the Rat Pack group on holiday gift ideas.
Yeah, I just realized it's something we don't talk about in this, or else I missed it. We didn't talk about that in with coax, or the adapters. That's something that no ham should be without a set of adapters for going from one type of connector to another. You're gonna start collecting those, and over time you'll have a large collection of adapters that can go from. We like to talk about being able to go from WR90 waveguide to BNC, or not BNC, to banana plug. So going from a piece of waveguide for microwaves down to a pair of banana plugs. And I've got the pieces to do that.
So this is what the list looks like, and you're welcome to attend our meetings, but they happen to be at 02 UTC, so they're not very convenient for your time zone, but we do record them all.
Brilliant, thank you. Right, anyone else with a question or comment to either Dennis or Anthony or both?
Yeah, I've got one.
Yes, come on, fire away.
Can you hear me?
We can, yeah, carry on.
Oh, good. Okay. Mike Zero, Mike Quebec Victor, Nigel, ex-member of your club, currently living in Cumbria, where it's -8 at the moment. There wasn't any mention, I think, of bandpass filtering, and my ex-file is also licensed, and we have a twin station shack, and we have installed bandpass filters so that we can run this at a contest station as well, because the antennas are fairly close to each other in a sort of 2-acre plot, and so we can run that. But the thing is, I understand that if you have two radios, and people may have just two radios connected, that even if the radio is off, if it gets a sufficiently strong signal, it can damage the radio if it's picking up a signal from a nearby antenna. And some of our antennas are, like 20-30 feet apart. And if you're running 400 watts through one of those, you can get a significant pickup. And so for people who just have two or more radios in the shack connected up at the same time, bandpass filters, I think, are a good thing. You didn't mention it. I just wonder what your comments are on that.
There are really two types of very effective band filters out there. One of the cheapest ones is to put together a set of coax traps that you can build.
Basically a stub filter.
Thank you.
Yeah.
And the other way is to build LCR filters in a box and do it that way. This is an article called Minimizing Interference on Field Day that I'm going to put a link in the chat for. And this talks about doing those types of things. And that is an issue when you're running two radios. And some radios are much more, as far beyond the damage aspect of things, just in performance, some radios are much more sensitive to having two or more radios in the area. And part of it is not because of the RF that's being put out by the radio in general. Some radios are much more noisy than you think they are. They're putting out some harmonics and spurs and things in the operating that don't go out long distances, but if there's two radios right near each other, they can be problematic. And you can often hear another radio in your shack operating more like an interference than a covering up of the RF source. One of the radios that's very notorious, and we found this out by people bringing in the field day, is the ICOM 7300. It's got a really open front end on it, so any other radio operating near it with that open SDR and no heterodyning or filtering or anything in front of it,
It's
an
a
open
direct
SDR like that
sample
is just, it's direct sampling SDRs can be really notorious for picking up other radios in the area and other pieces of noise in the area.
You either want band stop or band pass filters, depending on what your situation is. And the stub filters are a great way to do that. They're very low cost. You can, and I have to share that I made a mistake for field day. I put together a whole set of band pass filters for all of our stations. And I had a 500-foot spool of RG8U cable that I used. And after I was done, I was going, why did I do that? I could have just used RG8X because it's just on receive, right? It doesn't have to be, for the stubs, it doesn't have to be RG8 high power cable. It's just low power would work just fine. So I kind of blew it with that. I wasted a 500-foot spool of coax, unfortunately.
And after Dennis showed us his he showed me his well-built project, which looked really great. Then I said, Dennis, you could have saved all those coax connectors by just tying all the cables together inside of the box. So we made him feel bad because he just spent a lot of money, but he did an excellent job. So we shouldn't have done that to him that night, but we did when we were chatting about it. But yeah, you could put the bandpass filters together. Now, the important thing though, if you're using coax stubs, make sure you remove the stub before you change bands, or you can damage your own radio because
Yeah,
the
that's
stub can cause major problems if you're using the wrong stub on the wrong band.
So I made up these little, this particular one's for 40 meters. So I've got an input and an output. And then this goes out to the stubs, and there's 3 stubs for 40 meters to knock out the other stations on the other bands, 80 meters and 75 meters and 20 meters and 15 and 10. And so this is I made up instead of using a bunch of T connectors and all of that, which is what most people do, I made a little box to do it. So I've got one of these for each band that we were on. So, but you're right. Yeah. Doing this on a piece of PC board or something would have been a slick way to do it. But I did use UHF connector, so I can go back and redo this with RG8X and make it much smaller and lighter than it was.
Another thing too, when you're building those band stub filters, you can use different varieties of coax, but make sure you check the velocity factor, because we didn't mention that, but each type of coax, even though the impedance may be the same, the velocity factor is different, and they vary from manufacturers to manufacturers. So you want to get the specs of the velocity factor. And what that basically means is electrically, it's not the same length as physically. And typically the electrical length is much shorter than the physical length, because the velocity factors are a percentage of 1. Yeah. Sometimes as little as 60%. So they're significantly shorter coax. And by knowing that velocity factor and using something like a mini VNA, you can measure the coax without actually measuring it. You can actually electrically measure the coax if you know the velocity factor.
Yeah. I was going to share one thing also that I use here in my shack. I just pulled this out of the system here. I have separate receive antennas, and a lot of the radios I use have a separate receive antenna input. And especially if I've got a separate receiver and transmitter, it's real easy. But this is a little device from Array Solutions. They call it a receiver front-end protector, RF limiter arrestor. And it's basically a little device that you put on the receive input of your radio. You wouldn't put this on the transmitter side. You don't want to transmit through this. But on the receive side, it protects the receiver front end, especially the modern receivers, solid state receivers. This works to protect the front end of the receiver from lightning strikes nearby and from the stray RF. My receiving antennas, some of the receiving antennas I use are close to my transmitting antennas. So that's why I make use of this to have this in the system. That really helps a lot. They're fairly inexpensive. You could probably make one of these things very easily too. It's just got it's got a couple of transformers and a couple of diodes and a gas discharge tube in it. I don't know how well you can see that in there. It's fairly simple circuit. It doesn't really show up that well, does it? Well, there it is.
Yeah, you can see it.
Yeah, there's a couple of transformers, whereas there's a transformer there and a transformer over here. There's the gas discharge tube right there, that little thing. And there's a couple of diodes right there. And, so it's a simple circuit, but it'll protect the receiver. And that was a good point about that, though. Thank you for mentioning that. I made a note about it.
Yeah, well, that's why our presentations always get bigger. They never get smaller.
Go on, Nigel.
Yeah, I was going to say the stub idea is really good. I mean, obviously, we'd be changing stubs all the time, especially in a contest. We can't do that. So I did a lot of research. I looked at Array Solutions, DX Engineering have got some good stuff on there. But eventually I went for OM Power, and I don't know if you can see this. If I just show you that, can you see that box here?
Yes.
Yes.
Right. That if I switch it on, that's gone into bypass mode. But here, I can now change the bandpass filtering on all the major bands from 160. It doesn't do warp bands, but we're not using those for contests. And you could also put it in auto mode as well. And you need some frequency detectors, but you can, the Yaesu 5000, which I use, can switch this automatically. The Kenwood 990, I don't think can. So I would need some, another unit. That's the one. That's what we're using. but they're really, really effective. They just reduce the signal where it is harmonically related. Say, for example, if you're on 80 and you get a signal on 40, it just looks like another S9 plus signal from the other radio. But I mean, that's fine. You can handle it. So they're very useful. They're not cheap, but they yeah. Here you go. That's
this is another one. This is the DX Engineering model.
Yeah. Now that's good. I'm not sure that one was in stock when I did my research, but it was a year or two ago.
It's saying that it isn't in stock.
I have to tell you, this doesn't influence my talks at all, but I do occasionally write for the DX Engineering blog. Just want to let you guys know that if you ever see my name show up, and I also happen to live 13 miles away from the place, but I had to drive by the place when I went to and from work for a number of years, which is a very dangerous thing to do.
I was going to say that's not good. I had the same problem where I was working. I was just a couple of miles away from Ham Radio Outlet in Anaheim here in California, and that was real dangerous.
It was very it was very dangerous for me years back, because we went into a local ham radio store when my XYL got her first license, and we went into the local ham radio store, and the Kenwood had just released a 990, and they just got some in, and she went in and she looked at it, she said, "We're having that," and said, "Go and get your rate." So she traded in my 590S and bought that. So I wasn't really complaining, but you know, if I'd have spent the money, I'd have been dead.
Been in trouble.
But she can do it. Yeah. Anyway, thanks very much indeed, guys.
I bought my wife a Kenwood TS680. It was our first radio that had 6 meters on it, and that we both could use. I said I was buying it for her, so it was her radio. That didn't go over very well, but
no. And Gerald on here, Gerald, you were responsible because you got her through a foundation, but I got a radio out of it. Anyway, thank you.
It's great. That's great.
Right. Anyone else got a question or comment they want to put to Anthony and Dennis before we wrap up for this evening? Yes, go on, Keith.
Yeah, just a comment. When I first started controlling my 897 from my laptop, I had a severe problem with noise on the USB cable and solved it with clip-on ferrites. But later I've discovered that on Amazon, I found a whole load of different USB isolators. There were opto-isolators that opto-isolate not only the signal, but also quite a few hundred milliamps of power as well. And over here, I think I got them for 15 or 20 pounds. So it's another option.
Interesting. I've never run across those.
And I've heard a lot of people on the Kenwood TS590 list. The Kenwood TS590 SG is a great radio, but it does have a rather sensitive to static USB interface on it. So a lot of people on that list tune me into those type of things because they can be, blowing out that chip is no fun.
That's not good. I've never run into those. That's interesting. That's something I may want to look into.
And I had a failure last month. I was moving some stuff around the shack, and all of a sudden my USB connection to my Electrocraft K3 stopped working. And I was very panicky because I couldn't figure out what was going on. I thought I'd messed up one of the controls on the radio or something. I said, I'm just going to run another cable and test it just to make sure that I didn't dislodge the cable, because of course everything's a rat nest behind the desk. And my wife fed a cable down to me. I plugged it in, and immediately worked. And I came up here and I took the old cable and looked in the end of it, and there was some corrosion. It was a high quality cable, but one of the pins on the computer side of the USB cable had some corrosion in it. It was causing intermittent problems with the CAT connection.
Yeah, that'll do it. Interesting. An optically isolated USB. Interesting. That's cool.
You can buy little modules, Dennis, so you can use them with any USB cable.
That's I want to look at that. I've got one device here that, depending on what band I'm on, it's actually I mentioned that flex control, which is that little knob behind me there, that little tuning knob. once in a while, depending on what band I'm on, that thing will go away. It'll disappear. And it's obviously getting RF into the cable and messing with it. So that's something I'm going to look into. Ferrites should have taken care of it, but it doesn't. I still have that problem. So
now, all you beginners out there, don't want any of this scary though, because this stuff doesn't happen all the time, and if it does, it's easily solved. So
they are easily solved. That's true.
all the things we talked about today, you can really simplify a lot of the things we said and get on the air, and you will have fun on HF. And if you're not on HF yet, right now, with the sunspot cycle the way it is, and with 10 meters being wide open and 12 meters being wide open, you don't want to miss it, because there's going to be about a 5-year period, hopefully, of really good band conditions. Although what you do when the band conditions switch the other way is then you switch to operating 160 and 80, but it's not as convenient antenna-wise. But yeah, definitely get on HF right now, because the conditions are great. You're going to talk worldwide, and you're going to have a great time on HF.
10 meters should be wide open for us right now here. The sunspot numbers are really good. SFI is 153, sunspot number 174. That's great.
The 10-meter contest last weekend was pretty good.
K planetary index is 1, which is good.
The only problem I had during the 10-meter contest was the bands were so good I worked very few domestic stations because the band was much too long for them.
10 meters.
Am I going to wrap it up, or anybody else want to dip in with a quick question or comment?
I'd just like to say, Nick, as a pretty newcomer, you know, I only had my license coming up 2 years. I just want to thank you two for these talks. Really interesting. I have got an HF, but it's the way you deliver them is really good as well, because it's in understandable language to a newcomer, shall I say. So really appreciate your talks, guys. Thank you.
You're welcome. Appreciate the comments. Thank you.
Yes. And I just want to give you a quick advertisement. This again is on the Rat Pack coming up, but tonight at 02 UTC, but you can also watch the recording in a couple days. We're going to have a presentation from the chairman of the organization that runs the CQ DX Marathon. And the DX Marathon is a very simple contest, but it runs all year. And what you do is you count up the total number of countries you work plus the total number of CQ zones you work. So it's something you can work on all year, and I really like it because I've had DXCC for many years. So for you hams that have been out there and already worked 100 countries, it's a great chance every January 1st to reset your total and see how many countries you can work that year and how many zones you can work. So it's getting close to the end of the year, and I'm trying to get my totals up for the end of the year. So I'm looking for the Gabon at the expedition at the end of December. Even though I have already worked Gabon many times, I haven't worked them this year. So it gives you an opportunity where even the most mundane DX becomes very important. So one of the things, it uses the DXCC list plus the European list. So there's 5 additional countries. You get credit for the Italian islands off of Africa. You get credit for the different, the European Turkey. And one of them is the Shetlands, and I'm still looking for a Shetland station also. So if there's anyone on from Shetland tonight, or going to Shetland for the holidays before the first of the year, I'd love to make a contact with you. But again, you can find that information at the link I put in the chat on tiny.cc/ratpack-list. And we're always happy to have you either live or watch the recordings.
Yeah, well, you won't get Shetland just at the moment because they've had a massive power out.
Oh.
The island won't be reconnected till they reckon till the end of this week. So that's unfortunate, unless they're on generator, of course. But there you go.
Batteries, yes.
The other, I just remember with the other the fifth extra countries, they give you both of the 2 separate JWs. So both Bear Island and Svalbard count separately.
Svalbard.
Yes.
Yeah. Nice.
Okay, well, look, can I, on behalf of the club here, thank Dennis and Anthony for a brilliant second presentation. Can we all show our normal appreciation to them for their talk tonight. Cheers, guys.
Thank you so
very
much.
And
Thank you.
Can we
Thank you.
wish you both happy Christmas as well.
Likewise. Yes.
Have a lovely time over Christmas with family and so on, and maybe we'll make some contacts on the radio at some stage. I'm quite sure.
Wonderful. I was looking around. I was looking around for my collection of Christmas crackers, and I couldn't find them. I was thinking that would be really appropriate today, but my wife has never experienced that either. So, but thank you so much for having us. I really have enjoyed this. It's always a pleasure, and appreciate the comments. And it's a joy to be here.
And we'll see you for part 3 in the new year in February. So
Yes.
Sounds good.
Brilliant.
All right.
Okay, right. Thank you, everybody.
Merry Christmas.
Thank
Happy
you.
holidays.
Bye-bye.
Bye-bye.
Happy holidays.
7-3.
All the best. Bye-bye.
Good night.
Bye.